Good everybody. We are going to do statistics today. I'm John Newquist. As we talk about, we record the video. I had to redo this one because of the TI 30 issue, but I appreciate everybody coming in on the last session of this. So again, the questions are not the exact questions. I agreed to rewrite all the questions with the same principles. And let's get into it because statistics is tough. The average CSP, ASP question is getting 5 of them. You may get 2 calculations and 3 terminology ones, or 1 calculation, 4 terminology ones. And again, it's in domain 1 and for CSP and ASP. You got to know the mean, median, mode, confidence intervals, probabilities, Pareto analysis, central tendency, variability, and probability. Yikes. There are degrees in statistics. So our video of this is not going to make you an expert, but we're trying to get you through the items of the test. Let's talk about some nomenclature. Mean is the sum of the list of numbers divided by the numbers of quantity in the list. So if we have 5 numbers, we add them up, divide by 5, and give us our mean. Mode is what's the most common frequent value on the list. And that's a pretty easy concept. You just got to count. Median is exact middle. So if I have 5 numbers, it's going to be the 3rd number. Standard deviation is the tough one. That's where people just get excited. You need the calculator to do it. I've got the old method and I've got the new method. And you'll understand the on-screen calculator is a lot easier. If the low standard deviation, that means it's like a 0.05 or something like that. A lot of the numbers are closer to the average. If it's high, it's very well spread out. So our knowledge check. What is the mean of a data set? A, the middle value when the data is ordered. B, the most frequently occurring value. C, the average of all values in the data set. D, a measure of how spread out the data is. And it is C, average of all values in the data set. What is the mode of a data set? You notice these are the same answers. The average of all values in the data set. B, the value that appears most frequently. C, the middle value when the data is ordered. D, the measure of how spread out the data is. And it is B, the value that appears the most frequently. What is the median of a data set? A, the average of all values in the data set. B, the value that appears most frequently. C, the middle value when the data is ordered. D, a measure of how spread out the data is. And it is C, middle value when the data is ordered. What does standard deviation mean? A, the average of all values in the data set. B, the value that appears most frequently. C, the middle value when the data is ordered. D, the spread or dispersion of data points around the mean. And it is D, the spread of dispersion of data points around the mean. They use a lot of different numbers and words that you're probably never going to use for a lot of safety people if all you're doing is looking at hazards. But if you got to analyze the data, and that's where you might use the statistics. Measure of central tendency is a summary statistic that represents the center point typical of a data set. So if our median right in the middle is here, it's leaning a little bit higher. That means a lot of the numbers are, way beyond the level here. The mode is the most common one, and the mean is the average. In a perfect world, we'd have a bell curve for data, which is not what you want for like testing. You want people to pass the test, so you don't want them spread out from equal amount of failures to exceptional and everything else. The highest point is the most probable event and most likely going to be the mean in it. And the width of it is the standard deviation. In a normal bell curve, which is this is shown, within one standard deviation, you see that little circle with a little tail at the top? That's going to be the standard deviation sign. The mu, or the u, they're going to use Greek numbers. That's our median. So 68% of the data is one standard deviation from that. And that's important to know. Um, if it's perfectly symmetrical, they're all going to fall exactly right around this number here. And that's important. That's a question that you might run into. The width of the bell curve is described by a standard deviation. So within 2 standard deviations, it's going to be 95% confidence. And then 99.9 for 3 standard deviations. That means all the data should fall within that. Range is easy. Range is just the highest to the lowest numbers. What's the range of the test scores? 64 to 95. What's the range? 95 minus 64 is 31. So we had a score of 31 points from the highest to the lowest. Pretty simple, easy question once you just know what it is. What we do is when we look at the variance, in a normal bell curve, the B is going to be the sample in here. But we go around, and if we have high variance, it's a widespread, like our blue curve. So if we take all age groups and the use of the cell phone, we might find the average is 200 minutes for our median, or mean, but our standard deviation is quite high because, you know, the teenagers use the cell phone 9 hours a day. So that's going to be a lot different than somebody who might be elderly and maybe 30 minutes a day. So we're going to get a big spread of the data. Lower variance means they're closely clustered. So if I just did my group and I sample young adults, I could get a very close number. And it's used in a lot of data. Is it important for you? No. You just got to be able to know when you get something that's really odd. And confidence levels is, you know, our standard deviation. If it's within 2 standard deviations, that means it's going to have a 95% confidence, and 3 standard deviations, that 99.7. When you're doing testing and you start to look at the scores, if there's a bad question, you know, for such and such, we want to see what the average person got right on it, and we're expecting 60%, 70% right on our mean, you know, where our average score is going to be 70. But if we start to get to where it's random guessing of 25% and the meaning's way over here, that's an indication the test scores might indicate this is not a very good question, or there's confusion. Again, 95% is actually 1.96 standard deviations. You don't have to know that. It's usually called 2 standard deviations away. And 3 is going to be 99.9%. So when we look at different data, we've got a pretty high area. Not much variance here. It's all kind of clustered around. It's not, you know, you can see it's a much more steeper mountain than the other ones. And going back, oops, going back the other way, here we are. Again, low variance, closely clustered. High variance, very flat. So what does the measure central tendency describe? Here's a knowledge check. A, the spread of data points. B, the most extreme values in a data set. C, the center of a typical value of a data set. D, the relationship between 2 variables. It is the center of a typical value data set on a graph. In a perfectly symmetrical distribution, which is generally true regarding the mean, median, and mode. The mean is the highest value. The median is the lowest value. They all fall at the same central point. The mode is different from the mean and median. Remember, perfectly symmetrical. They're all going to generally be right around the same point, which is the mean. So now we're going to take the donut holes, and that's important because if I'm selling donut holes for a dozen, I hope we're getting a dozen donut holes. So they did some sampling and they see what the clerks are giving the customers, and they just sampled 9 bags, and there was 12, 10, 10, 10, 13, 12, 11, 13, 10. Right off the bat, if I'm the owner, I'm concerned because I could get customers complaining. You can imagine if McDonald's selling you 10 chicken McNuggets and they're starting giving you 8, there are going to be people saying they're ripping us off, and they're going to be very nasty on social media. So when we want to do the mean, all we do is add up these numbers, and we get 101. There are 9 numbers, so we divide by 9. Our mean is 11.2. Not so bad once you understand how to do it. The mode's easy. Now we got to put it in order, but you notice the 10 is jumping out. So mode is only one that has 4 is going to be 10, and that's our mode. Our median, what is the exact middle? Now we have to write it in, so it's going to be the 5th number since there's only 9 numbers, right in the exact middle, and it's going to be 11. Now we're going to get our TI-30X calculator because we got a standard deviation. And I'm just going to show it to you this way, and I'm going to put myself on the big screen here. Yeah, we'll go over here. So first thing we got to do is always turn the calculator on by the on button down here. And then we're going to enter the data by hitting the data button. So first one is going to be 10, enter, and you'll see it go like this. It'll have the 10 up there. We do this 3 more times. And I'm going to have to move myself out of the screen because I can't see all my numbers here. Okay. Then we have 111, so 11, enter, 12, enter. We have 2 12s, so we have to enter twice. 13, enter, 13, enter. And if we do it correctly, we should have at our screen here, focus it, we should have about a 13. Now we're going to hit the second variable stat button. Second is this light green button. Stat is above the data. So we get in here. It's kind of hard to see this. Okay, second stat. Now we're going to get our variable numbers, which is what we want. We want to calculate the variable statistics. So we enter. Now we get a little bit tougher here. We got this screen here that shows us data, frequency, and calc at the bottom right here. We have to use this down arrow. Get to the calc. And then we just hit enter. Boy, this is so easy. There's 9 numbers. Our X mu, which is our second line here, 11.2 is our mean. That's going to be the number, our average. Our standard deviation, 1.30. Pretty simple. So I'm just going to back this out, turn it on, enter the data. You get into the stats variable one. We're going to enter it, calculate, and enter, and then we get this number here. So not hard. We'll do it one more time, but for a lot of people, this is what there's a lot of anxiety on. So just practice this. Just practice it. Just knowing how to use this calculator. You're going to have to spend $15 for this calculator. The old way was to calculate the sum of the squares and take the square root of it. I'll let you read it here, but I mean, essentially, the deviation from the mean, which is 11.2, is 1.2 minus 0.2, 0.8, 1.8. We square all these 9 deviations, and we get 13.6 divided by the sum of the squared minus 1 is 1.6, and take the square root of that gets us 1.3. Oh, that's ugly. If you can make and do this, that's fine. You're welcome to do it. I can do it, but I don't want to do it if I have the calculator, because this takes time, and it's easy to make a mistake. So range, oh, wait a minute, we didn't do a range one. Range is highest to lowest, so 3 to 11. What is our range here? It is 8. 11 minus 3 is 8. The median of 3, 5, 3, 9, 11. Remember, median is exactly in the middle. And it is 5. A lot of people get confused when they start putting decimals, but the numbers at the top don't have a decimal. Just a subtle thing you might run into. The mode, most frequent number, 3, 3, 5, 9, 11. Your answers are 3, 3.6, 6.2, 5. It is 3, or A. Now the standard deviation. Again, we're going to go back and put myself on the screen here. Come here. All right. Now I still got my data in here from the last time. I can just hit data, and I can hit delete button. But I can get to the clear button right here by hitting the data again and hit 1, and voila, it's gone. So if you remember, we're going to enter 3, enter, 3, enter, 5, enter, 7, oh, there's no 7. Hit the clear button and it backs it up. So it's 9, enter, 11, enter. So your screen should be like this. Focus, focus, come here, camera. Well, there we are. See 5, 9, 11. Now all we have to do is calculate, hit second button, stat, and it brings us up. Do you want variable stats? Yes. And then we got to get to our calculate button by using our arrow button. And then we enter, and voila. 5 numbers. Our X bar, our mean, is 6.2. Our standard deviation is 3.6. Pretty easy for someone who's done it a lot of times. So the answer is 3.6. Here's what the formula looks like. You know, sum of the deviations minus the mean, square that number, divided by n minus 1. It's not easy, and I understand, but practice it. You'll do well. We're not done yet. We got probability too. That's another one. Square the deviations, calculate the variance. 13.2, square of 13.2 is 3.6. Woo! You could do it. That's a slow way to do it. I leave it up here in case you want to go through it. I don't recommend it because this is going to take you 10 minutes if you check your work. Where you say the calculator, if you do it over and over, you're going to do it in 2 minutes. You might check your calculation twice, but that's it. It's only a couple minutes if you know how to do it. Probability. If I have 10 bulbs and 90 good ones and 100 lot, if I just select one, I have a 10 out of 100 chance of being a bad bulb. Or 9 out of 10 is a good bulb. If I select 8 bulbs at random, what's the probability there'll be at least one defective bulb? Oh, this is an ugly question. This is, again, another college class just on doing statistics and probability. So the formula is, you know, minus the probability, or Q, is 1 minus the quantity of the bulbs to the 8th power, since we're drawing 8 powers. So we're going to figure out what percentage of the chances are the bulbs all going to be good. So 0.9 times 0.9 times 0.9 to the 8th, that's what we're doing, 0.9. It's going to be 0.43, or 57%. Your calculator will have a button on here for to the X power. But they're not going to give you 100 numbers, so I hate to say, I just get the board out and I just go 0.9 times 0.9 times 0.9 8 times gives me this number. Subtract it. Remember, you get a dry erase board, so you can just put it in there. But it's an exponential. Here we're going to have 100 bulbs from a manufacturer. Contains 10 defective, 90 non-defective, so same percentage as last time. Now I'm going to select 2 bulbs at random. What's the chance that both are defective? Well, it's 1 out of 10 chance on the first one. But now, when we do the second one, it isn't 1 out of 10 chance because we took out one of the bad bulbs. So what we're going to have, you know, in a sense like this, is it's 1 out of 10 chance for the first bulb. And our second bulb, there are 9 bulbs left that are defective and 99 total. So now it goes to 1 out of 11, which is like 0.09. So in a chance of both of them getting defective, it's going to be 0.1 times 1 divided by 11, or 1 out of 110. They may give you the number fraction, or they may give you the decimal. You can calculate that easily on your calculator. But that's a tough question. These are the ones you may not get any. You could take 5 or 6 of these tests in a row and not get a probability one. Statistics, it's been running 5 questions every test for a lot of people. Some people get lucky, get 3. Some people get 6. But most people, if you want to say what's the mode, it's going to be 5. All right. So what's our chances of both bulbs being effective? I did the calculation for you. And we would just sit there and say 1 divided by 10 is our chance, 1 out of 10. And then there's 9 out of 99. And we just multiply those 2 numbers. So our calculation would be 0.1. 0.91. 0.91. Okay. So just a calculation on it. Let's, you know, most time you got it 2 levels. They're not going to just ask you pull 1 bulb out of thing. What's your problem? That'd be too easy. They wouldn't give you that one. I don't think, at least I've never seen it. The Pareto principle is 80-20. It's good while it works, but 80% of the consequences cause from 20% of the causes. So, you know, you could say hand injuries are only 80% of our losses, but only 20% of our total injuries. You know, you could, you know, this is a number that they use, you know, for trying to say focus on the stuff that has the highest results. If 80% of your losses are from 20% of the injuries, that's a high reward to fix. Because if you fix this, then this drops, and it should be out there. If I go back in the old days, ergonomics is typically 40% of all injuries. And I would have companies not deal with ergonomics. Yet that's 40% of the injuries you're not working with. And that's not good. And so, you know, we definitely want to deal with ergonomics, because once you can get it, you can get down and cause a lot of these issues to disappear and save money. According to the Pareto principle, what percentage of accidents are caused by a small number of hazards? 80%. How can the Pareto principle help improve safety? A, by focusing on identifying and addressing most common causes of accidents. B, by implementing complex safety procedures for every potential hazard. C, by ignoring minor hazards unlikely to cause major accidents. D, by randomly selecting safety improvements without analyzing accident data. By focusing on identifying the most common causes of accidents. Okay. Any questions? It's tough. Statistics is very, very tough. So, again, remember, if you get 5 questions, you can get 4 terminology in 1 calculator question. And I mean calculator being a mean, or a standard deviation, or even a median or a mode. Those are calculations if you have to do them through your head. But I've had people say, I've had 4 of them. I got mean, mode, median, and standard deviation. I says, well, you hit the randomness of the test jackpot, and you can do well. Probability, I want to say, like I said, about 1 out of 5 tests are getting a probability question, and we give it to you. Pareto principle, about 1 out of 3 tests have it. So the idea is, if you get them, let's get them right. And I tell you what, if you can do the standard deviation calculation, you got it. You'll pass the test. All the questions are weighted equal, but it's such a confidence booster when you get that one right. And your mind is, hey, I did this tough question, and I will pass the test. All right, take it easy. I'll see you next month.